Let us look at volume as we continue the topic measurements. But before we do that, let's just review what we were looking at before. I have this ruler here. The inches section, normally you would find inches divided into half, then quarter, then 1/8, and so on and so forth. The inches on this ruler are measured in tenths for some reason. We also have the centimeters side at the top. We're going to use both units. Now, we're looking at lengths, and we say from here to here is 1 inch, and from here to here is 1 centimeter. See cm for centimeter. You don't see the word inches or inch here, but these represent 1 inch. So if we now form a square so that the sides are 1 inch long, then the area of this is 1 square inch. And if we form a square up here where the area of the sides or the length of the sides are 1 centimeter, then we have a square measuring 1 centimeter squared. And remember, the width in calculating the area, centimeter multiplied by the height, centimeters, gives you centimeters squared. So the length is 1 dimension, just the length. When you're talking about this, you have the length, or maybe you could say the width, and the height are 2 dimensions, 2 of them. In this case, you have the width and the height, 2 dimensions when you're talking about the area. So just the length alone, that's 1 dimension, that's the width. The area has 2 dimensions, width and height in this case. Now, let us look at volume. Let us say we still have this block or this square, and we add the turn dimension to it. You have width, height, and length. Each is 1 centimeter long. You notice what we have here is a block, a box. Since each side is the same in length, we say this is a cube. And the space that it takes up is the volume. So this is a cube. The amount of space that it takes up is called a volume. So the volume is basically how much space that is taken up by an object. Now, since the size of this cube are 1 centimeter, 1 centimeter, 1 centimeter, that is, it's 1 centimeter wide, 1 centimeter high, 1 centimeter long, then the area is equal to 1 multiplied by 1 centimeter multiplied by 1 centimeter. So 1 cm times 1 cm times 1 cm. And then what you get is 1 cubic centimeter. All right, so it's 1 cm cube, with the cube normally, the 3 is normally a superscript, but you can call this 1 cubic centimeter as well. And you notice 1, 2, 3 centimeters are multiplying, so you put a centimeter cube here. So this cube is 1 centimeter cube. The volume of this cube is 1 centimeter cube. What about this one? This area here, this square, let's turn it into a cube. So we have the height and we have the width, we have the height. Let's put a length to it, where the length is also 1 inch. So we have 1 inch by 1 inch by 1 inch. Okay. Let me draw it a little more proportionate. Okay, so this that you get again is a cube. Alright, it has all the sides equal in length, and here it is 1 inch wide, it is 1 inch high, and it is 1 inch long. Let's put some dimensions on it. 1 inch wide, so it's from here to here. It's 1 inch wide. And you have 1 inch high. This height is from here to here. Okay, and then it is 1 inch long. So looking at the length, let's put it from here to here. This is the length of it. And this, of course, is also 1 inch. So the volume of this cube is 1 cubic inch. 1 times 1 times 1. 1 inch by 1 inch times 1 inch. Height times width times length. That's how you calculate the volume of a cube. So here now, let's do a little modification. Let's get rid of this, and we're going to add another cube to this. 1 centimeter, 1 centimeter, 1 centimeter. Each distance is 1 centimeter. Alright, you can see through this cube. So let's just erase this section of it, pretending as if we cannot see through it. Now we have 2 cubes stacked on each other. So the width now is no longer 1 centimeter. All of this as 2 centimeters wide. But at the same time, the height is 1 centimeter. 1 centimeter high, 1 centimeter long. Since the height of it, the width and the length are not all equal, you call this a cuboid. This is now a cuboid. Alright? Now notice the width of it from here to here is 2. You see that? The height is 1 centimeter, the length is 1 centimeter, but the width is 2 centimeters. So what is the volume? Well, you can see that it's supposed to be 2 centimeter cubes here. But let's write it out and calculate it. So the volume of this cuboid would be 2 centimeters multiplied by 1 centimeter multiplied by 1 centimeter. All right. So this cuboid here. The volume of it. Let me change the color. The volume of this cuboid is 2 centimeters multiplied by, so it's the width multiplied by the height 1 centimeter multiplied by the length 1 centimeter. 2 multiplied by 1 multiplied by 1 is going to be 2, and it is centimeter. 1, 2, 3 of them multiplying, so it's centimeter cube. You see that? So this is the cube that we're referring to here. Okay, good. So, well, I said the cube, it's a cuboid. If the sides, all the sides are equal in length, then it's a cube. If one of them is different, even if 2 of them are the same and the third is different, or all 3 of them are different, the width, the height, and the length are different. Maybe the width and the height are the same, but the length is different. Whatever the case is, as long as they are not all equal, you say it is a cuboid. Alright, good. Now, what we're going to do next time is look at a few examples of volume, and we will mention some of these examples as they occur in practice. Alright, so that will be it for this video. I will see you in the next video.